Hello grade 12s. Today I am looking at a past paper. Here is the 2019 paper 2, and I'm going to be looking at the mechanical analytical. When we're doing that, try and remember that in our reading time, do the reading of the mechanical analytical as your last aspect of the reading time, so that as you've finished with your mechanical analytical, you can start the paper. As far as time allocation is concerned, you've got 20 minutes to complete this, so get used to doing it in that time frame. So my time at the moment is 12:39, let's call it 12:40, so I need to be finished by 1 o'clock. So let's go through this and see if you've got the same answers. So I've started our first couple of questions here. NTS not to scale, pitch circle diameter, Woodruff key, your tolerance is plus minus 0.25. What is the maximum and minimum dimensions? Part A and 1. So we look at that measurement, and that dimension there is 52. So what we would do is we would say 52 plus 0.25 gives me 52.25 is the maximum. The minimum would be where we subtracted, so subtraction would be 52 minus 0.25, giving me 51.75. Question 6, the type of hole. Here is the hole. Now it could be two aspects. One is it's got this little slope on the side, which means it could be a countersink hole, and that's because it's got those sloping sides, a countersink hole. Or because there is a space here where the shaft could be, this is where they could be putting oil into that space. So it could be a countersink or an oil hole. 7, the type of sectioning in part C. At 3, so this is where they've taken that shape and they've turned it and flipped it into that space, is a revolved section. Feature 4, here is the S break, which is showing an interrupted view. Feature 5. Okay, this is a shaft, and it's very much like the symbol for first and third angle. So what is happening here, it's going from one diameter to another. It's a taper, it's sloping. Feature 6, so we see the hidden detail, and when we come to the other view on the side, we can see it's this little slot here, which is where the key is going to fit. Okay, so the keyway. Calculate the dimension of 7 in part I. Here they're checking whether you know your calculations and formula. This is a nut. The height for a nut is 0.8 times the M value. So if we come down to the information here, it's saying it's an M20 nut. So our value here is 20 times 0.8 gives us 16 and the type of sectioning at B. Okay, so here's the cutting plane and here's the shape. Now, keys about this, or clues should I say, about this type of section is if there is an angle on our cutting plane and these do not actually line up when you project. Okay, so if that's the case, this is what they refer to as an aligned section. So they're imagining that instead of where that cutting plane is there, they've turned this vertically and then they've done the sectional view. Okay, so remember those clues. It doesn't actually line up when you project, and there is an angle in the cutting plane. That's an aligned section. What is the total height of part A? Okay, so here are our heights. We write them all down here. So there I've got my 20 plus my 57 plus my 32, and now I need this distance. When I come across here, it's a radius of 50, and I add all of those up to get my answer. When I add all of that up, I'm coming up with 159. Which part prevents the coupling from sliding on the shaft? So in other words, what is holding it in place? So when I look at it, here is the coupling. It's this little aspect here, and what's going to fit in there. As I look across here, I'm seeing this grub screw. So chances are this grub screw is going to fit into that coupling, which will then tighten onto the shaft. Okay, and there's the hidden detail on the shaft where that grub screw will fit into the coupling and then go in there. Okay, so that's the grub screw to hold it in place and prevent it from sliding. Okay, a square weld on site. Okay, the on-site symbol is the circle that is coloured in, and the square butt weld to vertical lines. On the next side, what do we need to do here? Okay, so perpendicular, you've got to know this information, so you've got to spend some time practicing and learning this information. So inside here, the perpendicular symbol is just like maths. There's the perpendicular symbol, fits on the inside here. When the machining process goes on the top here, that is grinding, and then they wanted the surface roughness value, and that goes in here at 0.2. It is now 12:50. It's taken me 10 minutes to finish that, and I've scored 10 minutes that I can then add on to other drawings if I run out of time. And that is the IEB final, Mechanical Analytical 2019.